So just a quick bit about me is that I'm a software developer from London. I do Node and I do PHP as well. So again, if any of you are hiring, definitely get in contact with me. My email address is going to be at the end, plus my business cards should be floating around as well. I'm a Laravel contributor, WordPress contributor. Yeah, you know, WordPress, can't go wrong with WordPress. And then a bit more about me as well is that I run a platform called Idea. It's an API platform. And I currently have 4 APIs live at the moment called 3PS, PIN, P2M, and Civil Analytics. 3PS we just spoke about there is a 3D printing API. The idea being is you can post like STL files there, and then we'll just actually send you the return to printed file. PIN is for pinning IPFS blocks, but we'll skip that for now. P2M is PDF to mail, so you can post your PDF files to us, and then we'll like print it and send out certified mail, and we'll track it as well. And it's like webhooks and stuff, so you know when it's delivered and whatnot. So my project, VueIPFS, the idea behind it is it's a simple Vue.js framework that allows developers to easily get started with Vue.js without having to have like a really deep encyclopedia knowledge of how IPFS works. In a nutshell, it becomes prepackaged with Bootstrap, Font Awesome, Video.js, and Vuex and Vue.router. And it also comes with, I think, 5 template pages. So once you've cloned it, you can just edit the pre-designed templates and just start deploying it and start getting people like sharing it. So this is basically how it works. What you do is the application that you clone uses 2 Docker containers, an IPFS container, and a simple Node container, which is running Vue.js. When you run Docker Compose up, what happens is it will boot up these 2, the IPFS container and the Vue container. And whenever you compile your code, or when you compile the Vue code, it will then push the compiled code to the VIPFS container, or the IPFS container, and it will deploy it to the IPFS network. So let's quickly touch on what exactly is IPFS. I'm sorry to fill the page of text, but that is really a very succinct and clear way of getting a grip of what actually IPFS is. So IPFS stands for the Interplanetary File System. It's a P2P distributed file system that seeks to connect devices using the same file system. It provides both decentralized and permanent web that offers several benefits, such as high throughput, DDoS protection, no single point of failure, and a content address storage model, as well as a version file system. This section at the bottom here explains quite clearly how, explains quite easily how to put it. It's a very succinct definition of IPFS. It's basically a shared Git store that basically exchanges files using a similar approach to how the BitTorrent protocol used to work. So what you get is, the idea being is that this is how the internet works right now, okay? In this centralized model here, where content is on a server somewhere, typically in AWS servers or GCP servers or whatever. And when you go to say prooftechnologies.com/page, the request will go to the server and then you get the response back. Now this isn't the most efficient way to design networks, because what happens is, or a way to think about it is, if we all want to stream the same video here in this room, we will all simultaneously be communicating with YouTube servers to stream that video down, and then we'll be watching it. So we have all of this all this bandwidth is being wasted to play this one video file, when we can actually just, one person could use it and then share it between everyone right here. This is how the decentralized model of IPFS works. The whole idea being is that all nodes or all participants in the network are both simultaneously servers and clients. That they can serve files, they can also share files, and they can also essentially cache files for the rest of the network. So if we were to have we live in the alternate universe where the internet worked like this, I would stream the YouTube video down, or one of us would, and then your laptop would then say, where's the nearest copy of this data that I want? And it'd be able to collect it from my laptop. So the problem we have at the moment is that there's actually a huge that the centralized nature of our internet is making it exceptionally easy for corporations and government to take away our First Amendment rights here in the US. We see over here, Alex Jones, down the road from us in Austin, Milo, we've got Lawrence Southern there, who've been completely deplatformed, unilaterally taking away people's way to earn money and also to actually exist in this digital world. And it's not just here in the US, have the Arab Spring, when was that, back in 2011, 2012, where the government would just shut off the internet. So even in our developers here, especially in the Middle East and in Asia, like here in Hong Kong as well, governments just unilaterally shut off the internet for everybody, and they have that kind of power, which means that no one can speak, no one can get any information from the outside world. So this is VRPFS is the solution. We aim to address some of these problems by democratizing the IPFS technology, making it so almost anyone can easily create an app or a website or a blog or an e-commerce store, regardless of your kind of technical ability. So let's go to the risky part, which is the live demo. So for this, yeah, I know this is always fun, right? So, can everyone hear me? Yeah, awesome. Okay, so to get started with the IPFS, simply clone the repository from GitHub. So just simply run a git clone, and you clone the repository. Should take a few minutes, and then boom. So once you've what you get into the repository, it should look like this, or in fact, sorry, a better way to put it is like this. This is what the repository looks like when you actually get inside it. It's just, as you can see, it's a very simple kind of like boilerplate for a Vue.js-based project. All your code is stored within the SRC directory, and then these docs and storage is where the docs is stored in the documentation. Pardon me. And in the storage directory, this is where you can store things like large media, so things like images and videos and PDF files, all this kind of stuff. If you put any files in the storage directory, whenever you deploy your application to IPFS, it will also copy all that data across as well. So you can actually store in your application like big files, images, all that kind of stuff. So once you've cloned the app, once you've cloned it down, to get the app running, so you have to run Docker Compose. Now, when you try and do this yourselves, this might take about 15 minutes to have to pull the images down and compile them and whatnot. But be patient, it will work eventually. This is what you get when you've when you've booted it up. You have your IPFS container running, and at the bottom there you see the app is listing on port 8000. So what I'm going to quickly do is skip to this tab here and just run an npm run build. What this is going to do is it's going to compile all those pre-designed templates that I mentioned, and it will. So now when we navigate to localhost 8000, we should see the default welcome screen. So this is the default welcome screen to IPFS. What we can do first is let's have a look at some of these templates. So the post template is just a really simple blog post. It's nothing fancy whatsoever, but again, it's just very, very simple Bootstrap-based blog post template. We've also got the video template here. And this is to demonstrate the video playing functionality, that you can also stream videos, both over the plain HTTP and also via IPFS. It's only a short, like 30-second video, but demonstrates the point. Another one is a gallery template. Again, it's nothing fancy, just a gallery of images. And last but definitely not least is the payment template. So something I wanted to kind of achieve with this as well was to make it really easy to create a Vue-based application that can exchange money without the need of a payment processor. Okay, so that's what this template goes to demonstrate. So if I actually click the buy now button, you may not be able to see it, but as you can see, MetaMask here has actually said I've attempted to make I've clicked the buy now button, and what that will do is that will actually then instruct MetaMask to make an Ethereum transaction. So this allows you to, within a few commands, you can make a web app that can actually exchange Ethereum for products and services online. And again, completely decentralized, doesn't require a payment processor, doesn't require any kind of intermediaries. So what I'm going to quickly do is demonstrate how you can quickly modify this bio page. So you can actually deploy a bio page on IPFS. So that's what we're going to quickly run through right now. So let's get started. So what I'm going to do to start with is, in the Vue application, let's go to the routes file, and I'm just going to clear out all of those routes except from the bio page, and I will set that to there. And there's also the command watch as well, which will just like loop and watch every time it detects a file change. So that will compile any seconds, and we're good. So now when I've gone to the home page, we've got the this bio page. It's like card template. Now, if we now I can edit that page quite simply. So now you can see it's pretty straightforward to edit. Like this doesn't require like you don't need to be necessarily like an expert web developer to actually do this stuff. So once you've edited a page, in fact, what I'm going to do is I'm also going to change those images as well, just so you can clearly see. So again, like I said before, any content you put in that storage directory will also get deployed to IPFS as well. So what I can do now is I can boom. Okay, so that I've updated that bio page with my information. And what I'm also going to do as well while I'm here is I'm just going to remove that header just because it's not necessarily doing anything fancy at the moment. So there we go. This is a really simple bio page. It's got just my images and it's also this downloadable link here. So I can actually share a PDF document with people. So what we've done so far is we've cloned the application and we've got the development server running and we have a really simple Vue.js based application running locally, right? But to actually share this with people over IPFS, you need to publish the content. So you need to actually put that file into that shared file system, as I discussed at the beginning. The way I've done that is I've made a command using the kind of packet, packet.json. Yeah, so there's a really simple command called npm run publish. And what this will do is this will put that compiled application onto the IPFS shared file system, and then it will also create a pointer to that file that will never change. So throughout, what actually happens is every time you edit any files and put it into IPFS, you'll get a new reference to that file. Okay. Now, what I've done is I've managed to make it so that it will make a pointer to that file as well. That will never ever change, even if the file changes. So once this is finished publishing, which may take a few minutes, I'm not sure if it will happen right away. That hash that it outputs will be a hash that you can essentially give to anyone, and they can run their own gateway, or they can just go onto the HTTP gateway on Google Chrome, and they can actually be able to get your file, get your project down. So it usually takes about 5 minutes. It gets faster the longer you run. The longer the container's been running, it gets faster because it's connected to more peers. But right now, there you go. Boom. So this hash here represents a pointer that will never ever change to your compiled application. So to see that, what I mean in practice is if you go to localhost 8080, now what we're doing is localhost 8080 is pointing to this container here. And this container is providing us a gateway, an HTTP gateway into the IPFS network. So what we can do is we can go to localhost 8080, IPNS, and we can paste that hash and boom. So what's happened now is we've, instead of requesting that from the node, node dev server, we've actually requested that through our local IPFS gateway. But additionally, if you go on Google and type in, say, IPFS gateways, there's tons of available public gateways that operate over HTTP. What you should also be able to do is if you open up any of these public gateways and type in IPNS / again, that hash, that pointer to the file, and that your website or that project should now be accessible over this gateway as well. Now, this won't actually load straight away. This might take up to 20 minutes plus to do, because what's happening now is the gateway that IPFS are maintaining, that gateway is now I've sent that HTTP request, which is executing right now, as you can tell by here. It's now, their gateway is now looking for the files stored on my laptop right here, and will then try and send those back to us in kind of via HTTP through the browser. So once you've run that command, that npm run publish, you can then share that hash with your friends or whoever you want to share access to the site with, and then they should be able to also request that file either here through the public gateway, or they can just run their own gateways by doing docker run. Yeah, I mean, we're basically at the end now, so I'll have some questions.
Cool. So every time you publish, every time you have a new version of
yeah.
that, basically all versions that have ever existed continue to exist?
Correct.
Gotcha.
Well, with an asterisk. Well, what happens is the previous versions, but obviously the data still needs to exist in some form somewhere, right?
Sure.
So if you were to delete those files, and then say those files never got out to the rest of the network, they would become inaccessible, right? But providing, and FYI, the way it's configured to start with, all the previous versions should remain on your computer, right? But if you deleted the previous files from your local machine and it didn't get seeded to the rest of the network, those files now become inaccessible as well. That's right.
Interesting.
So when you run npm run publish, are there central authorities? For example, in blockchains, you might have some central, something centralized, right? But you have some major authorities.
So that's not how IPFS works. It works like similar to Git, where you can work offline and you can still kind of commit. So when you publish to IPFS, there is no central authority. It simply just uses libp2p to then be able to distribute hash tables. I'm not an expert with maths, the actual math behind it, but it uses distributed hash tables and libp2p to then inform everyone else on the network where that file is. So the way that I believe the way IPFS works is that I would request the nearest person to me, and then you would be able to say, hey, where's this file? And you would get to the actual point where this is where it is, and then
so it propagates all over the network.
Yeah, it works that way. So there is no authority, there is no central authority. So the brilliant knock-on effect of that is that means you can run independent one as well. So you can just have your own in your office if you wanted to, and the same principle works. So yeah, it does.
So does it propagate once it's requested by another source, or does it just propagate as soon as you publish?
So as soon as you hit the npm run publish, what I can do is, yeah, sure, let's just freewheel this for a little bit. If I go docker exec -ti, okay, so what I've just essentially got, this is a shell now in the IPFS container. So if I do this and just go, okay, so cd temp, okay. So if I just do echo Vue.js to so if I do that, I can just cat like that. So I've just created a single HTML file with the word Vue.js added to it, right? Now, if I want to go and add that single HTML file to IPFS, I would just go IPFS add index.html. Now, it's giving me a hash. This hash is a reference to that one file, right? Now, if I were to do this, I don't know if it's got. I'm trying to how can I edit? No, I'm thinking how can I edit the file without nano? Fuck. But the bottom line is no, because I'm in a Docker container right now, so so I don't know if the Docker container has it. I could probably use sed or something, but I'm not going to. What's that? Well, I was just going to add another character to the string, so it's different. The idea being is that whenever it changes, when I run that command again like that, I'll get a different hash because the file has changed.
Oh,
so this is
just run that same command again.
what's it? Oh, will it?
Just run the same, like,
Oh, double arrows?
You'll modify it.
Oh, okay, sweet. I didn't know. See, I learned something new today, huh? Yeah, awesome. So if I then try and add that file again, this is a new hash, right? But one of the brilliant parts of IPFS is that identities are shared with keys, right? Like private public keys. What I can do with IPFS is I can get a pointer to this file, sign it with my public key, then publish the that's what's called the that's what happens when you run the publish command. Is what you're getting back isn't this hash you're getting here. It's a signed pointer to this hash. So what happens is it will add the file, and then it will also create a pointer to this file with your signed public key. That's why it never changes. So under the hood, every time you view publish, it's publishing new data to IPFS. It's also re-changing that pointer. So that hash itself never changes, but the location that the point is pointing to does change. And it will all happen with that npm run publish command. That's why you don't need to necessarily worry too much about it. But under the hood, that is how it's working. Yeah, it's pretty cool stuff.
So on one of the descriptions of IPFS, you mentioned that almost anyone could join. So if you can expand a little bit more like caveat,
So the caveat was in the word almost was actually in reference to the IPFS. What I meant when I said almost there was that obviously you need some level of web development knowledge to use the IPFS. That's what I meant by almost caveat. But a weak coding course and you can use this, right? You don't need to be a genius. But with regard to IPFS, no, it's open standard. You can clone it and you're now running your own node. There is no intermediaries or authorities or anything like that that's associated with it at all. If anyone's thinking of actually reading up more about this, one thing I really would recommend is the guy who created IPFS did a talk at Stanford. I'm signed in, so I'm going to get a load of odd suggestions here. There you go, Joe Rogan. This one here, the Stanford seminar, let's see, 4 years ago, it's old. Watch that, and he goes to a really deep dive about the protocol, its uses, why it's why they created it, all this kind of stuff. If you have any technical questions based on IPFS, I would definitely watch that 1 hour video because it explains everything from the horse's mouth far better than I can explain it. So I'd really recommend checking that out. Any other questions?
I'm assuming the Vue stuff you're doing, it's just all server-side rendered at the end, so it's basically a static file.
No. They're quite the opposite actually. So it's all client side. It's all client side. So I can touch on that as well. So when you have that npm run watch command, what it does is it will compile. In fact, I can actually open up the Webpack. So this is basically what it does. Really, really simple. It compiles the CSS and it compiles the JS and it moves the index.html to the build directory. Yeah. And then it also moves the storage directory to the build directory. Yeah. Now, when you run the command, publish, it does this under the hood, right? Who knows much about Docker? Are you all Docker familiar? Yeah. Okay. Cool. It runs in the IPFS container. It runs the command sh and triggers this script file here. Okay. What that script file does is in IPFS publish. This is the script file. It adds, that should be build really. I don't know why I renamed it. But it adds the build directory and then it publishes that name. So all that's getting published to the network. There is no server-side rendering. The whole concept of server-side rendering doesn't really exist with IPFS. So all it does is just bundle those files and save those files. That's all that gets put onto the network. So when you make that request to the index, you can access that and all of the other the JavaScript and CSS that's required to render the page. It's all done at once.
And there's no issues consuming standard APIs once you're in there.
Can you elaborate? What do you mean by consuming APIs?
If you want to say, pull in a Twitter feed.
Yeah, so I've already touched on that. No, not that. I mean, I've already dealt with this example because someone raised it before. So if you notice on the home page, you'll see it says current GitHub stars.
Okay.
Yeah. Now, the reason why I put that there is just so there's an example use of Vuex, right? So, what? Maybe a little too big. Said no one. Zing. Yeah, so literally all the reason why I put this like just a bit of boilerplate code is to demonstrate exactly your question. That yeah, you can. So although it can be served over IPFS, you're doing a plain HTTP connect request here, right? And it's just saying, right, get me like the JSON for this current repo, and then like yeah, get the Stargazers count, and then commits that to the store. So yeah, it can consume standard APIs.
So building on top of that, then could you, because IPFS you said kind of runs on top of HTTP, right?
Parallel.
Okay. So could you actually do like an Axio Git with that hash that you?
Yeah,
So you can actually
you could. The reason why so you could simply, if I wanted to, I could commit a JSON file to IPFS, right? And then I could retrieve that file over the gateway of that.
Because IPFS still static. So
that's correct. Yeah. So I could retrieve it, but that wouldn't necessarily be really useful technology because because you need to then maintain that gateway, right? So like you would either need to run your own private gateway so you can ensure that's always up. We'd have to trust the third party that their gateway never goes down. So like to answer your question, yes, but in practice I probably would go about that way.
right. Okay.
No worries. Need more framework?
Something's better converting the relative links to hash codes for the links into the IP FS.
Yeah.
Right? What part of the stage did that, right? I mean,
So
share out your routes, right?
Yeah.
You got a route that had a link to 4 different pages.
yes.
Those pages were all internal to your application.
Correct.
But if you browsed it through a gateway and got
A directory back.
you got a single file back, right?
Yeah.
You get the HTML.
Yeah.
There's a hyperlink into it. It should be back into the.
Yeah. So it's kind of one of the things I've tried to like gloss over. Actually, it's actually one of the drawbacks of this. So to be hand on heart is that it doesn't use the history. It doesn't use history view routing. It uses hash view routing. The problem being is that, and frankly, it's a flaw in IPFS, if I may say so myself, is that to actually access IPFS, you have to go like /IP IPFS here, right? What that means is that you can never use the history in your like client-side rendered application. You couldn't use the history feature with regard to view route. So you have to use like relative links. So to answer your question, like the way it works is the whole application is built using relative links. So if you'll notice here, for example, where I'm like referencing a stored PDF, notice there's no like / at the start. Because
so that storage document prints.pdf is actually being mapped somewhere to a big hash.
yes.
Right? Like go back to the web page. Just inspect the element there. Like what's the what's the URL of that image?
Okay, so the URL of that image, it will literally be this, because this hash is actually pointing to a directory. So if I go to that image now, what you see is that. And in the network tab,
Yeah. Oh, okay, so that hash is a directory. Okay.
yeah, that hash is a directory, yeah. So, I mean, if I wanted to, I could just go cd root @ls. And what it does, it goes IPFS add -r, no, cd dot IPFS add -r. There you go. So that's what's happening under the hood. Is that it says individual hashes point to every single element, or all the files have their own unique hash. But exactly this one here. So I could actually run this if I wanted to. I could actually just run to publish that to use my private key to sign a pointer to this hash here. I would just go IPFS name publish that. And now it's going to create that pointer for me, right? But like I said, all of that stuff happens in the publish command. So you don't need to get your hands dirty with it per se, but that's exactly how it works, yeah. So, cool. Any others? Any other questions? No? Awesome.
So now that's
Cheers. Thanks, guys.